Okay, let's consider here one beam of length equal to L measured parallel to Z axis. This one is Y axis and this one is X axis. So here this plane is in the XY plane. So L is the length and this is the width equals to B and this is the depth equal to D. And let's say that it is subjected to UDL or whatever the load it may be. Now if you draw the SFD and BMD for this one, we are knowing that since a simply supported beam, we have a bending moment. The SFD for this case is, this force is vertically upward, this is the UDL, so we have a line like this and then we have a reaction on this side. As far as the bending moment diagram is considered, is it bending moment diagram is maximum at this point and this one is a line, so is it a parabola? So it will rise and it will fall like this. So at somewhere we will take one section here. Let's say this one is a section here at distance equals to what? Dx. So this one is basically the distance x and let's consider this thickness equals to what? Dx. So right now we are interested in this area. So is the bending moment on this side and the bending moment on this side is different. So we'll analyze this portion. So for analysis purpose, let's consider this section. This one is A, this one is B, this one is C and this one is, and we slightly enlarge this section. So this section was rectangular. Before we apply the load is something like this. So this value equals to dx. This is same as dx. This one is A, is equals to B. This one is C and this one is. Now the bending moment at these 2 points are different. So we are making a generalized case. Let's assume the bending moment is going this way. So this bending moment, if I say M, then this bending moment will be equals to M plus dm. Because of this bending moment is this portion will go this way and this portion will try to enlarge. Which portion will enlarge? If you find here, you will find that the A will come to this side, D will come to this side and B will come inside and it will go like this. So there is a curvature form here and there is a curvature form here also. So is the length of AB has become A dash B dash now and the length of C will come as C dash D dash. So what you conclude from this one is because of this bending moment is the member length AB, the fiber length AB is decreased and is the fiber length CD will increase. Okay, so we'll take out this part and we'll analyze again. So first observation is that the member top fiber is shortened, means compression, and is the bottom member is elongated. So bottom fiber is elongated. So that will be in tension then. If the member length increase, it will be in tension. So here this one is my initial part. Now this member length has decreased, this member length has increased, means there must be one member which neither increases nor decreases. So let's say that member is somewhere here. So is the length of this member is same as the final length? Is the length as this member has changed or not changed? Not changed. So that we called as neutral fiber. So this one is E, this one is F. Before applying the bending moment and after applying the bending moment is the length of EF is changed, remain constant. So EF is called as neutral fiber, but it has a curved portion slightly. And now what we do is that since it's a curved portion, we'll extend this line somewhere here and we'll extend this line somewhere here. And let's say this makes an angle equals to d theta. So line A dash D dash has extended, B dash C dash has extended and it form an angle equal to what? Del theta. Now whatever the measurement you want to do, you have to measure with respect to EF. So above this, it's a Y value. Is it Y value? So Y was taken as positive and below this, Y is taken as negative. That is the sign convention. So on this one, we are setting the axis. At neutral axis, we have set it. So above this, Y is positive and below this, Y is negative. It means that the bottom fiber, is it correct? Negative value and top fiber is positive value as far as this sign convention is considered. Now we have to define all these things. What is neutral axis and all those things. But first of all, we'll go for this one. Now I suppose the figure has become little bit complicated. So we'll draw a separate figure. Now this member I will call as D dash C dash D dash. And this member we are calling as EF. EF is called as neutral plane. With reference to this neutral plane, we'll measure the radius R. So this one is called as radius of curvature, which is either denoted by R or denoted by rho. And then we have one top fiber. Top fiber is somewhere here. So this top fiber is basically A dash and B dash, and this angle equals to del theta. So before deformation, this length was dx length is same as EF length, and EF length is same as R multiplied by del theta. EF length before and after remains same. EF is same as delta dx, and is that length is same as R multiplied by d theta. So what is the original length? Is basically dx. Is it same as R multiplied by d theta. Theta in radian. If you observe the A dash B dash, we have to take this value equal to what? Y positive. If you take this one y positive, anywhere we can take a y positive, then is this distance will become from here to here, is it a R minus y? This distance is what? This one is y. So basically this R minus y. So if you go on the top side, it's a R minus y, and if you go below this, it's a R plus y. इसके ऊपर हम यहाँ पे R है हमारा, इसके ऊपर हम जाएंगे और यहाँ से गिनेंगे तो R minus y हो जाएगा, और इसके नीचे हम गिनेंगे तो R plus y हो जाएगा. So new length will be equals to R minus y multiplied by d theta. इसका नया लेंथ कितना आ जाएगा यहाँ से लेके यहाँ तक? R minus y into d theta. And original length is this one. ओरिजिनल लेंथ हमारा इतना था, तो हमारा यहाँ से स्ट्रेन फॉर्म हो जाएगा. तो हमारा स्ट्रेन कितना फॉर्म होगा? स्ट्रेन मतलब क्या होता है? चेंज इन लेंथ. चेंज इन लेंथ मतलब हमारा हो जाएगा न्यू लेंथ माइनस ओरिजिनल लेंथ. तो हमारा ये वैल्यू हो जाएगी R इंटू डी थीटा माइनस y इंटू डी थीटा. ये न्यू लेंथ है, माइनस R इंटू डी थीटा, ये हमारा ओरिजिनल लेंथ है. सो चेंज इन लेंथ डिवाइडेड बाय ओरिजिनल लेंथ, इज इट अ स्ट्रेन? So this one is strain is equal to R of d theta. तो हमारा यहाँ पर R d theta और R theta कैंसिल हो जाएगा, और बाद में हमारे पास बचेगा माइनस ऑफ y by R, क्योंकि हमारा d theta और d theta भी कैंसिल हो जाएगा. तो माइनस साइन हमारा ये इंडिकेट कर रही है कि अगर हमारा y पॉजिटिव होगा तो हमारी स्ट्रेन क्या होगी? नेगेटिव होगी, मतलब कॉम्प्रेसिव होगी. अगर हम नीचे आ जाएंगे न्यूट्रल फाइबर के तो हमारा y जो कहेगा वो नेगेटिव y हो जाएगा. तो नेगेटिव नेगेटिव क्या हो जाएगा? पॉजिटिव हो जाएगा, और हमारी स्ट्रेन क्या हो जाएगी? पॉजिटिव हो जाएगी, मतलब टेंसाइल स्ट्रेन आएगी. मतलब वही बात हम कर रहे हैं कि हमारा टॉप मेंबर किस में आएगा? कंप्रेशन में आएगा, और बॉटम मेंबर किस में आएगा? टेंशन में आएगा. ओके, व्हाट इज द रिलेशन फॉर स्ट्रेन फॉर अस? इज द स्ट्रेस इज गिवन बाय स्ट्रेन डिवाइडेड बाय इनटू ई. सो कैन वी से द स्ट्रेस इज इक्वल्स टू माइनस ऑफ y multiplied by E divided by R. E, I, R, all these are positive value. So again can we say that stress on this fiber will be the compressive stress, and this stress will be tensile stress. So from this we got relation, that is sigma equals to sigma by y, is it a minus of E by R.